Statistical Rethinking, second edition, chapter 13, and we're on the very last problem of this chapter, 13H4. Okay, here's the question, but instead of reading it, I am going to go back up to 13M1 because this problem is essentially just a continuation of 13M1. So let's get familiarized with 13M1 here. So what we did here is we took the data called reedfrogs, where we were predicting survival, right, as a function of some other variables, and we kind of layered in these variables across several models. So at the very beginning, or at the very most basic model, we just had a random intercept for each tank. Okay, and this was the model that was presented in chapter 13. Or I think it was in chapter 13. But anyway, and then we began to layer on things like predation, as well as the size of the tank. And we had a random intercept for the size of the tank. And then we had both size of the tank and predation. And then we had both the size of the tank and predation, where we've interacted the size of the tank with predation in the final model, right? So the final two models are predation and tank size are additive, and in the last one there's an interaction between the two. Okay. And what we were tasked with looking at there is if and how this sigma tank parameter changed as we were layering in these different variables here. And what we found at that time was that with the most basic model we had, so the most basic model meaning just the random intercept for tank, right, the most basic of the models that we used, we had a sigma tank value of, whatever it was. The absolute value of it is not really important here. But once we added predation, it shrunk. If we did not add predation and just had tank size, it did not really seem to make an appreciable difference. And again, once we add predation to the model, whether it's additively with size or interactively with size, we get similar reductions in sigma. And so what we tentatively concluded at that time was that predation is apparently explaining something about survival across these tanks, because when you add into the model, sigma, our parameter for, basically our uncertainty, roughly speaking, is getting less. And so if when we add predation to the model, our uncertainty gets, our sigma value gets less, then we might infer then that our uncertainty is reducing, which must mean then that predation is doing some explanatory work in helping to predict or explain survival. Okay, so now in 13H4, we just continue that by saying, okay, well, does it bear out that predation does have some, causally explanatory role here? So all that we've done here is I've just completely copied that code that we just looked at, okay, and I've ran all of the models already, and I've reproduced the plot here where we're plotting sigma tank across each of the models here. Okay, and you see the same pattern. And so again, the tentative conclusion was that predation is apparently explaining something, and size does not seem to be explaining something. Okay, and so what we're going to do is we're going to look at the pricey outputs of each of these models and look at the coefficients for size and predation, tank size and predation, and so on. Okay, and so let's start here with the first beta predation model, where we just have beta predation as the explanatory variable, and we see that it is reliably negative, right? So it's well, the entire, what is this, 89% credibility interval is, it's negative. So that's interesting. And now if we go to the analogous model that only includes size, we see that its credibility intervals very heavily, and not exactly evenly, but pretty evenly, straddle 0. So in other words, adding size to the model, the effective size, if any, is very, very ambiguous, right? It's not clearly positive, not clearly negative. Okay? And so now when we have both of the, we have both predation and size in there additively, we see the same pattern where the coefficient credibility intervals for size is pretty ambiguous, but for predation is pretty much pretty convincing that it's negative. Okay. And once again, when we have the full interaction model, we have that the credibility intervals for size are pretty ambiguous, and for predation are pretty convincing that it's negative. Okay, and so again, all of this goes to support the idea that predation really does have some kind of causal explanatory function in explaining survival, and size does not. Again, what are the two lines of evidence that we have of this? One is, as we add predation to the model, our sigma value, right, kind of the unexplained bits of our data, gets reduced, but not when we add size. And also the coefficients for predation, but not for size, are pretty clearly on one side of 0, suggesting an effect. Okay, that is it.